Thank you, Amon, for your talk and your kind words. And I can say that it's been a privilege for me to work with you as an employee and as a colleague as well. Sorry? Okay. So this is my title, and I'll just start with, since we're a little bit behind time here, no conflicts of interest. In Alberta, we are respectfully acknowledge that the University of Alberta is situated on Treaty 6 territory, traditional lands of First Nations and Métis people. And these are the funding sources for the results and studies that I'll talk about today. And some of the ideas that we have from Alberta Innovates, CIHR, CCNA, synergies about ABRD, and NIA. So I have one theme and three parts. My theme is from big dynamic data to precision detection and more inclusive promotion of brain aging research and resilience. The first part is on exploring what longitudinal approaches can reveal about the dynamics, variations, and determinants of pathways toward or away from healthier brain aging. And for this, I want to integrate some thoughts about, of course, group differences, which we talked about, individual differences, which we talked about, but also inter-individual differences and inter-individual change, between person differences and how people change over time. And the question there is, could heterogeneity and individualized trajectory distributions present an opportunity for research on diversity-related differences in brain aging risk exposures and brain health barriers? Second part, very brief part, will be on exploring brain and cognitive trajectory data in resilience research. So applying the previous issue to the current topic, where I want to try to enhance precision of resilience detection, precision of risk predictor identification, and precision of possible diversity barrier conditions and considerations. And then inclusion. So these are trajectory distributions. This is the first part. These are from different data. The one on the upper left is from ADNI data, hippocampal volume data, trajectory data, atrophy data. And the one on the right is multimorbidity data, frailty type data in the Alzheimer's patients. And I'll start with where some of the talks have started as well, and that's with the mean differences. These are mean bars. You see on the bottom, the x-axis, it's average memory performance, episodic latent variable of episodic memory, for 55-year-olds, 65-year-olds, 75-year-olds, 85-year-olds, and 95-year-olds. And if these were cross-sectional data, I couldn't do this. That is, link them up as though it's a trajectory, as though it's an average change over time. It actually is, for another reason, not recommended to do it. And the other reason is that these individual differences within each of these ages is tremendous. It's they are almost covering the entire range of possible performance in episodic memory latent variable, and they overlap dramatically. So one doesn't want to interpret mean differences or group differences with that kind of variability surrounding them. But in addition, one thing I haven't mentioned, I hinted at, is that lurking behind these means are actual individualized trajectories. And these are individualized accelerated longitudinal design, somebody mentioned this morning, of episodic memory over time. And this big black bar going across this curve, growth curve, is in fact the average performance of that entire distribution. But another thing I haven't mentioned is that by applying some AI data-driven type technologies, we can detect underlying subgroups and subtypes of these distributions. So we're analyzing the trajectory distributions, not just the trajectories, not just the performances, by feeding it an algorithm of level of each individual and slope for each individual. And that turns out to look like this. The best fitting model had three subtypes to it, or classes, and those subtypes are labeled red, blue, and green. Doesn't tell us too much just yet. So that gives us a little bit more information. Then I want to go back to the means bit and show you that these groups, these subtypes within the same distribution, are quite different in terms of their mean performance at each of these age groups. And then let's take it just a step further and take a look at these, where we were before, where we started with, And that is the mean age differences across this range of 55 to 95 100-year-old persons. And then compare that to the mean differences within age across these subtypes that have been detected through this AI technology. And that tells me that that's a really important difference that we're observing within these trajectory distributions. So let's go back to this, move it over here to the right, and then add some ages in it. Now, what do we have in this study? This is an NIA study, Victoria Longitudinal study. What we have is some young adults and some middle-aged adults. We have 800 or 900 of each of these. So these produce pretty reliable means, but that doesn't tell us too much compared to all the rich data we have for the longitudinal studies. And there are some other studies. I know Yakov mentioned one that he has, and PATH study in Australia has this as well, that have longitudinal data earlier in life. We don't have that. So what do we want to do here? We want to try to interpret these a little bit richer than red, blue, and green, and say that, and the blues are kind of normal, mild decline, and the greens are lower level, obviously, and steeper decline, maybe pre-impairment, maybe in that direction as well. We want to also note what the constituent processes are of these. Some of these people who are probably in the red group are there because they have sustained aging exceptionality. They've been doing it, whether or not they're resilient or not, we don't know, but they're resilient to age, I suppose, but not specifically to any other kind of modifiers. Another one is resilience to AD adversities. Some of the people in this aging group from 55 to 100 will have AD adversities, such as the ApoE4, which was mentioned earlier. And they're resilient to that adversity because they're still performing at a very high level of performance. Long-term stability is present in most of these groups, especially the reds and the blues. Normal decline is present within the reds near the end and also within the blues. And steeper pre-impairment neurodegenerative disease is represented also perhaps in the greens. But let's try to look a little bit back and at a higher level of analysis at what kinds of influences are emerging in later brain phenotypes might there be. We mentioned some in this talk, in this session, and also all day: sex, gender, diversity issues, SSDH, SAS, brain health, access, brain health barriers, intersectionality. These are all lurking in the background of people who are moving through early adulthood and middle adulthood into later adulthood. And we have a lot of categories of risk factors and protection factors. Many of them have been mentioned in these talks today. We call this the exposome. What are they exposed to? They include such factors as lifestyle, genetic, AD risk factors, education, vascular health, physical activity. All the things that have been mentioned today are part of these categories of the work. And so the platform we would have here would be that there would be some that are non-modifiable and risk factors, some we can't change, like ApoE, E4 positivity. Intersectionality perhaps could be another one that's not so easily changeable. The goal would be to promote resilience in midlife and continue that, support that throughout early adulthood, young adulthood, old adulthood, and later adulthood. The actionables might be at the level of person, sex, or other subgroup specific conditions and characteristics. And we would look, in the case of modifiable risk factors, we would want to identify which ones are relevant for predicting healthier brain aging and do some precision reduction of those risk factors and then support that process. And we also want to not forget, as many people have said already, that we have also modifiable protection factors, identify what those are, and facilitate and support that as much as possible. Let's move quickly to resilience then. So this is a pathway model I first did with Margie Lockman from Brandeis in 2019, but I've been updating it, doing a little bit differently each time I present this. I last presented something like this at Jillian's conference on women, brain, sex, health a couple of months ago here in Montreal. But this is adapted now, yet again. I keep changing it, so I don't know if I'll ever get to a final version of it. So here are the three trajectories. On the left, we see a column of possible trajectories. And we have now the classes that we were able to identify. And this is the higher level stable slope class. That's the one most of interest to resilience researchers. And this is how that could be developed through adversity or barrier risk that's normal, normal risk reduction, and heterogeneous actionable targets after that. What if you have high adversity or high barrier performance, and you have elevated risk reduction? Then that could be a resilience, adversity-related resilience. You may also have lower adversity and lower barriers, but elevated protection factors or risk reduction factors, and that could lead to stability or exceptionality. Now, the typical resilience research is looking at the people in the reds, and I don't know if that's really necessary. So I asked a couple of questions here to myself, and the questions were, to resilience dynamics of risk elevation, adversity, reduction, or protection apply only to higher sustained trajectory patterns? Could consideration of sex, gender, diversity, and inequality of risk reduction lead to the possibility of resilience processes for normal BCA, the blues here too? Maybe it takes resilience to stay in that when you have a lot of adversities or you're facing a lot of barriers for healthy brain aging. And so then I asked myself, well, what do we want to do to enhance precision of all this? And I said, we want to consider sex, gender, access, intersectionality, stigma, diversity, inequality, all the keywords we've been talking about in this meeting so far. And they apply at all of these stages or phases of overall involvement. So again, I got to this point, but I didn't stop here. I went further with machine learning prediction models to see what is predicting, what sort of modifiable predictors do we have within this particular data set that predict the red group, being membership of the red group versus membership of the green group. And what we found was that, first of all, we had to disaggregate. We didn't disaggregate by sex in this case, but we disaggregated by age. Young old adults are not the same as old adults. So it's not like if you have 60-year-olds and 90-year-olds, you just throw them all together in the same sample. So we divided that and then tested which of these predictors were unique to the young old group, which were common for young old and old old, and which were unique to the old old group. And we found, in fact, that there were some in each one of those categories. And then we also wanted to predict the predictors, or understand and predict what is actually the risk factors associated with declining memory membership in that secondary phenotype. And we found that they were not just the reverse of what we found this for predicting stable memory aging. They were not even the reverse within age groups, but they were different. And so the predictors were quite different depending on where we looked at within the age range from 55 to 95, but also whether they were predicting stable memory or declining memory membership. So what are these predictors? Was sex part of it? Sex was indeed a predictor for both young and old of the stable memory aging, with females being more likely to be in that class than males, but not of declining memory aging. What about gender? Well, these are a lot of variables that we identified within our roster of modifiable risk factors that are gender-like. We've done some other work to identify these as well and then use them in other data sets. These are gender-type variables that you can pull out and look at them as predictors as well. What about diversity? Well, we didn't really have diversity. This wasn't a diverse sample, but these are variables that are relatively interesting to diversity. And when I read the diversity literature, I see these are the kinds of things that are being identified as being important for that. So even within this sample, which wasn't designed to look at gender, it was designed to look at sex, also diversity, we did find that. Okay, so I'll go ahead to resilience. I have just that to do. So this is a study we did in 2017 in Journal of Gerontology, and then we repeated it in 2023, I think it was, in scientific reports with Australian data with Karnansky involved. And we looked at ApoE as a specific precision predictor or adversity to which people could be resilient or not. And we wanted to know specifically if males and females were both could both show that kind of resilience, and whether they were predicted by different kinds of modifiable risk factors. So I won't say too much more about that. So the precision stratification here was disaggregation by sex or gender, and the goal was to resilience to AD risk predictors vary for females and males. First thing we had to do was find out, are there any resilient to AD risk, for instance, in this age range. From this again was 55 to 100 or so. And were there some in both subpopulations? We found for the ApoE4 group members who were present in this larger sample that there were indeed two classes, some of whom were doing very well with episodic memory, and some of whom were declining. And we found those also for males. And so these groups became more resilient. So this is an operational definition of what we mean by resilience, and both males and females showed it. So then we just did the sex predictions very much like we did for the other study. Data-driven predictors, machine learning type prediction models. And we found that some were predictive for only females. Some were predictive for both females and males. And only one was predictive for males only, and that was fewer depressive symptoms. So then we went back and said, well, okay, so which one of these are modified gender-related predictors? And I've identified those with the green boxes here. Which one of these are functional health predictors? And that's sometimes associated with diversity differences. And these are identified in the blue boxes. And then which ones are modifiable diversity-related predictors, and identify those with these dark green boxes here as well. So I'll end with very few 5 concluding comments. Again, I want to mention the databases I've been using for this study: the ADME database, the NAC database, the PATH Australian database, the Victorian Longitudinal study. And these are the funding agencies for these particular studies that we put on here. So looking forward to promoting resilience in BCA and aging, brain cognitive aging. I have primarily questions, but also we've done a little bit of work in that direction as I see. I find that there are abundant opportunities of inter-individual differences and inter-individual changes in brain and cognitive aging for this kind of work. This is an interesting way to look at it, the individual differences in inter-individual change. Longitudinal designs integrated with AI-derived analytics can reveal latent dynamic subtypes or secondary phenotypes. And numerous databases are available, as we've seen a few people have also been using a number of databases too. We use quite a few too for mining, but also for disaggregation. Our resilience pathway is dynamic, multifaceted, and multi-determined. AI-related technologies can be applied to enhance precision of resilient pathways. Does studying aging plus and operationalized adversity provide deeper precision in some resilience research? I think it might, and that's the direction that we're pursuing right now. Precision detection in context. Really important to do this in the context that we're discussing in this conference. Do some resilient pathways vary by adversity, by diversity, by sex and gender, by SES, by SSDH, health accessibility, or health barriers? This is quite probable given what we heard today and what we've been sort of examining or checking or exploring in our report recently. And modifiable risk factors in context. Might they operate dynamically, interactively, and differently in terms of efficacy for these different subgroups that we would want to say? We'll look at. I think, and there's evidence now to show that this is quite possible, that in the context of prevailing person-specific adversity, lifespan, age, sex, gender, SES, and SDH, the risk factors themselves may operate differently, may predict